If you look at the cells of the innate and adaptive system, the monocytes, neutrophils and mast cells form the innate system, and the B cells and T cells are part of the adaptive system, and some cells function as part of both. The innate immunity kicks in a few hours. We evolutionarily have this immunity so that we can respond at once. The complements form part of the innate immunity, and adaptive immunity takes a while, but it's very specific. I've already mentioned this, it kicks in at once, this takes a while. This is quite non-specific for a variety of pathogenic organisms, but this is specific for that pathogen that has attacked us. And the innate system doesn't need any help to recognize the pathogen. It just can recognize the PAMs and start reacting. This one needs help. They need help by the antigen presenting cells, and it will recognize peptides presented in the context of antigen presenting cells. The innate system cells has ready-made tools like granules to destroy the pathogenic organisms. This adaptive system has to produce tools. So this one is ancient and evolutionarily we have it, and usually they say that's no memory, but some seem to have. But this one definitely has a memory, and we adapt to new challenges and new organisms. This is the phagocytic process. So once the chemokines are released, the phagocyte goes there and it recognizes the PAMs, and then signaling events happen and it starts the phagocytosis. A phagosome is formed, and then the lysosomes attach to the phagosome and form a phagolysosome, and then lysosomes release all their contents and destroy the pathogenic organisms. The T cells have on them something called a unique T cell receptor, and the B cells have the immunoglobulin they produce. They put it on the surface as their receptor, which is also unique. Now let's look at the complement system. The complement system is a set of proteins that are circulating around, and when needed they get activated into a cascade. There are different pathways of complement activation, alternative, classical and lectin pathway, but ultimately this is the end result. The end part of the pathway is the same for all. This is also a very interesting concept, what the complement does. At the end, it forms a membrane attack complex, which is actually punching a hole into the surface of the pathogenic organisms. So you can see this like a funnel, and the solutes can go in and lyse. So this is the side-on view, and this is the end-on view of the complement, membrane attack complex. Again, this is the same thing. Just to show you, it's like C9 is polymerized, but all these, it's a cascade that follows, and the polymerized C9 will form a membrane attack complex, which is basically holes in the membrane.